Hello and welcome to today's video lecture. Today's problem is a bit difficult when compared to the previous problem. It is a combination of UDL as well as point loads. Okay, if you came to know how to solve this problem, it is easy to understand all the previous problems. Okay, this is a difficult one. If you know this one, it's better. That indicates you know the concepts very well. Okay, this is a question is as follows. A 3-inch parabolic arch shown in the figure is subjected to a UDL of 25 kilonewton for a distance of 10 meter from the right hinge. Draw bending moment diagram and also calculate normal thrust radial shear at quarter span from left. Okay, that's what they are given in the question. See, the figure is as follows. Okay, this is a figure. They are given 2 point loads. One it is 40 kilonewton, another one is 100 kilonewton. 40 kilonewton is acting 4 meter from the left hinge. So this is left, this is right. Okay, from the left hinge it is acting 4 meters, and 100 kilonewton is acting from the 40 kilonewton, it is 5 meter. With respect to left hinge it is 9 meter. Okay, that you have to keep it in mind. And also they are given in the question that there is a UDL of 10 meter length which is acting from the right hinge. So that UDL magnitude is 25 kilonewton. So year to year distance is 10 meter. That's what they are given. So procedure will remains the same. First step is to find out the reaction. Next step is to find out the slope and rise equation. After that we have to find out bending moments at the loaded points. Then we have to draw the bending moment diagram. After drawing the bending moment diagram, then we have to calculate normal thrust and radial shear. Okay, yeah, listen carefully here. Loaded points are, that is, in order to calculate bending moment we have to calculate at point D because there is a 40 kilonewton load, and even we have to calculate at point T, there is 100 kilonewton load, and also even we have to calculate at this point where the UDL will start, that is F, and we know if it is a UDL exactly at the center we will get the maximum bending moment. Even we have to calculate for this UDL center, I am considering it as G, so that also we have to calculate. These are the points where we have to calculate the bending moments. Okay, first step we will follow the same, finding the reaction. F of x equal to 0, VA minus that is HA minus HB, that will be equal to 0. Then I can consider HA equal to HB, then it is equal to H. And next condition, f of y, VA moving upwards, VB moving upwards positive, minus 40 minus 100 minus 25 into 10. Okay, that, and then I am considering moment at A equal to 0, then 40 into 4, okay, 100 into 9, 25 into 10 into centroidal distance. Here to here it is 20 plus 10 divided by 2. Okay, that you have to keep it in mind, and that I will explain it here. Okay, so reaction f of x equal to 0, then HA HB equal to H, f of y equal to 0. These two forces are moving upwards, these three are acting downwards, so it will be 390. Then I am considering moment at A equal to 0. Moment at A equal to 0, 40 into 4, 100 into 9, clockwise positive, 25 into 10, magnitude of UDL. Centroidal distance is 20. See here to here it is 20. 20 plus 10 divided by 2. Okay, that's what I considered here. Okay, minus of VB into 30, that will be equal to 0. VB value we came to know, that is 243.67 kilonewton. Substitute that one in this above equation, you will get VA value, it is 146.33 kilonewton. Okay, after finding VA and VB, next step is to find out the horizontal thrust. Okay, you have to remember this figure. Anyway, I will show this one whenever needed. Okay, so next step is to find out the horizontal thrust H. For that I am considering moment at C equal to 0 for left hand side. For left hand side I am considering. Okay, then you will get 1 2 forces. This will be perpendicular distance is 6. For this year to year distance is half of the total span, it is 15. And for this 40 kilonewton we know year to year distance 15 minus 4, it is 11. Okay, year to year 100 multiplied by perpendicular distance year to year total distance is 15. 15 minus of 9, it is 6. Okay, that's what I considered here. Summation of moment at C for left hand side, VA multiplied by 15. Horizontal tends to rotate anti-clockwise, and this one minus 40 is also tends to rotate anti-clockwise, and its distance is 11. Minus 100 into 6, that will be equal to 0. From that we came to know H value. Okay, you know H value as well as vertical reaction, that is VA and VB. You have to calculate their resultant, that is RA and RB, that you know. Just we have a formula of resultant. RA will be equal to root of H square plus V square, and RB will be equal to root of H square plus VB square. Okay, and we know the direction. We have a formula, tan inverse of vertical by horizontal. At point B, vertical is VA. Sorry, at point A, vertical is VA and horizontal force is H. Similarly, at point B, vertical force is VB and horizontal force is HA. So you can substitute the value directly, you will get the value. Okay, yeah. Then we know after finding the reaction, next step is to find out the rise and slope equation. So rise and slope equation is as follows. That is for 3-inch parabolic arch, y equation will be 4h into x divided by L square whole multiplied by L minus of x, where we know H value is, they are given 6 meter and total span is 30 meters. Substitute that one, you will get rise equation. Similarly, if you differentiate this one with respect to x, you will get slope equation. Okay, after finding rise and slope equation, next step is to find out the bending moment. Okay, bending, in order to find out bending moment, we know at the hinges it is 0. That what I considered here. We know at the hinges it is 0. That what I considered. Moment at A will be equal to 0. Moment at B will be equal to 0. Moment at C will be equal to 0. Okay, after knowing this one, next step is to find out the bending moments at different portions. For that, I am considering first portion as A to D. Okay, yeah, listen carefully. I am considering first portion as A to D. A to D means it will be like this, A to D. Okay, only this portion I am considering. So we have one vertical, one horizontal, another one vertical force. Only this portion I am considering. We are finding moment at this, bending moment at this point. Force moving upwards, positive bending moment, downwards, negative bending moment. Vertical force I am talking about. Yeah, horizontal force, it is negative bending moment. Yeah, the figure is as follows. We have to find out at point D. 40 is acting at point D. No worries. We don't know what is the perpendicular distance here to here. I am considering it as YD, and we know here to here horizontal distance as 4 meter. They are given in the question, and we know horizontal force H, and as well as we know vertical force VD. So I am finding bending moment at this point. Horizontal force minus H into YD, VA into 4. That will be the bending moment equation. But we don't know what is YD. For that, we know the rise equation. If you put x value as 4 in the rise equation, this 4, then you came to know YD value. YD value will be 2.774 meters. Okay, substitute 2.774 meter in the above equation. Then you came to know the bending moment at point D. Okay, why we consider at D means we know we have to find out bending moment at the loaded point. Here we have 2 point loads. One is acting at D, another one is acting at E. So we have to calculate at both the points. Okay, yeah, that will be the maximum, that is bending moment at point D, that is 51.35 kilonewton meter. Okay, next step is to find out another one portion, that is another one loaded point E, that is portion A to E. Okay, for that just I will show you. See, this portion I am considering, this is E, so this total portion I am considering. Okay, so where we have 2 point loads, one vertical force moving upwards, another one horizontal force. Okay, that looks like this. Just for your clarification, we know ear to ear distance is 4, we know ear to ear distance is 5, and we can consider directly ear to ear distance as x will be equal to 9 meter here. We know ear to ear distance, I am considering it as ye directly. Okay, yeah, ye, then that indicates portion A to E, So when force moving upwards produces positive bending moment, horizontal force negative h multiplied by ye minus h multiplied by ye, vertical force moving upwards va multiplied by perpendicular distance here to here is 9, and another one vertical force acting downwards negative bending moment minus 40 into here to here perpendicular distance, they are given it as 5 meter. Okay, simplify this one. We don't know what is ye value. For that we know the rise equation. Substitute x value as 9 in the rise equation. You came to know what is ye value. Okay, that rise equation, you know, substitute the x value as 9, then you came to know ye value as 5.045 meters. Okay, 5.045 meters, that will be the rise value, and substitute that rise value in equation 3. Substitute that rise value in the equation 3, that is ye. You came to know what is a bending moment at point E. Okay, after finding bending moment at point D and E, now we have to find out for the right portion. Right portion we have a UDL. Okay, that you know already, you have a UDL. So what I am doing is I am considering the loaded point, because why I am following this one means we don't know where exactly we'll get the maximum bending moment. That's the reason. So I am considering this one as a loaded point. So previously the UDL is for throughout span, that's the reason we considered exactly at the center. That indicates exactly at the center we'll get the maximum bending moment. Now it is not given for the full span. Here they are given only for the particular span of 10 meter, that too from the right inch. Okay, for that what I am doing, just I am considering F as a point, that is a point where the UDL is acting. Another one, for this UDL the centroidal point is G, that is ear to ear distance is 5 meter. Okay, at this point also I am considering. Okay, so for that keep it in mind. First I am considering portion B to F, next I am considering portion B to G. Okay, clear? Yeah. Why? Because means we don't know where exactly we can get the maximum bending moment. That's the reason. Okay, that you can see from this one. Yeah, I am considering first for the portion B to F. Okay, B to F there is a UDL up to point F. Here to here x distance is 10 meter and UDL is 25 kilonewton per meter. We know H value, even we know VB value. Okay, I am finding bending moment with respect to x. This will tends to rotate, negative bending moment, sorry, this will produce as negative, this will produce as negative, this will produce as negative, this will produce as positive because moving upwards, this will produce as negative because it is horizontal. Okay, VB perpendicular distance with respect to F is 10 meter positive, H perpendicular distance will be YE, and UDL negative 25 year to year distance is 10 multiplied by perpendicular distance from F here to here of 10 divided by 2. Okay, that what I consider. Here the unknown is that is YF. That is, for to find out the unknown YF, we know the rise equation. If you substitute 10 meter this x distance in the rise equation, you came to know what is YF value. Okay, rise equation, you know, substitute 10 meter x value as 10 meter, then you came to know YF value is 5.34 meters. Okay, after finding YF value, next step is to substitute the YF value in equation 4. Then you came to know what is the bending moment at point F, and it is 158.8 kilonewton meter. Okay, after finding for the portion B to F, as I told earlier itself, we have to consider another one portion, it is B to G. Okay, that is half of the UDL portion. Yeah, half of the UDL portion means it is total UDL is 10 meter, half of that one is 5 meter. Okay, G is somewhere located here, so ear to ear distance is 5 meter, and we know we have H value as well as VB value we have to calculate at this point. Okay, then the procedure will remains the same. VB multiplied by perpendicular distance is 5 meter, H multiplied by perpendicular distance is YG, but it is negative because horizontal. UDL negative because it is acting downwards. 25 into perpendicular distance, sorry, 25 into 5, and its perpendicular distance is 5 by 2. Okay, I am considering this one as equation 5, and unknown in the equation 5 is YG. In order to find out YG, we know the rise equation. Substitute x value as 5 meter in the rise equation, then we can easily find out YG value. It is 3.335 meter. Okay, substitute yg value in the equation 5, then you can easily find out the bending moment acting at point G, that is 263.89 kilonewton meter. Okay, after finding the bending moments at the silent points or the loaded points, then we have to draw the bending moment diagram. So bending moment diagram will looks like this. Positive will be in the above the axis of the arch, negative will be below the axis of arch. Here all are positive, so above the axis of the arch. Listen carefully. We know at point A 0, at point C 0, at point B 0, because it is hinge. Okay, hinges, wherever hinges are there, at that point bending moment will be equal to 0. And we know at point D it is 51.35 kilonewton meter. At point E it is 145.85 kilonewton meter. And we know at point F it is 158.8 kilonewton meter, and at point G it is 263.89 kilonewton meter. Okay, very important thing is, see, year to year we have a point load, so it is an inclined straight line. Okay, year to year also a point load, inclined straight line. Year to year also no load, or we can say, then you can write it as an inclined straight line. And C to F also there is no load. If you want, you can check the question, then you came to know C to F also there will be no load. That indicates it will be inclined straight line. Okay, then F to B we have UDL. Okay, F to B we have UDL. Before that we know G is the maximum one, it is 63.83. so year to year it will be a curve, then year to year it will be a curve. Okay, like this you have to draw the bending moment diagram. All are positive, so it will be above the, what we can say, above the axis of a centroid, above the central axis of a central axis of the arch. Okay, and we know after finding bending moment, next step is to find out the normal thrust as well as radial shear. So normal thrust and radial shear at the quarter span means, quarter means it should be total span divided by 4 will gives the quarter. That what I considered here, that to left, from the left hinge. So total span is 30 divided by 40, that will give the quarter span, that is 7.5 meter. Yeah, see from the figure, we know year to year it is 4 meter, and then 7.5 meter somewhere here. It is after 40, it should not reach us 100 kilonewton, somewhere here. Then we can say year to year distance as 7.5 meter. Okay, that's the reason I considered the figure as it is. Okay, 40, after 40 it is 3.75 meter. So we have one horizontal, one vertical, and another one vertical force acting downwards. Okay, we know normal thrust it is h cos theta plus v sin theta. Radial shear it is h sin theta minus v cos theta. We know h value, it is horizontal thrust 192.49 kilonewton. We have to calculate theta value as well as vertical shear. Okay, vertical shear we have to consider only the vertical loads in that section. Here we have VA moving upwards positive, another one is 40 kilonewton acting downwards negative, that what I considered. Then it will be V value will be 106.33 kilonewton. Okay, after finding V value, in order to find out the slope value, what we have the formula, that is in order to find out theta, we have the formula, that is the slope equation. I am considering the slope equation as it is. Put x value as 30 meter total length, and we know h value, even the rise value also we know. In the problem they are given that one as 6 meter. Okay, but what we don't know is x value. So x value they also we know. Year to year distance we came to know, that is where we have to find out the radial shears, that will be 7.5 meter. Substitute all these values in this slope equation, then you came to know that tan theta will be equal to 0.400. Okay, or 0.400 it will be. Then tan inverse of 0.400 it will be 21.80. Okay, I am considering theta value as 21.80 and V value as 106.33 and H value as 192.49. Substitute all the three values in the normal thrust and radial shear, then you will get normal thrust as well as radial shear. Okay, substitute all the unknown values in this equation, then you will get normal thrust and radial shear. So that is as follows. Normal thrust will be 218.211 kilonewton. Radial shear will be minus 27.24 kilonewton. Okay, there ends your problem. It's a bit complicated one. So if you know how to solve this problem, it is that indicates you know the concept very well. Okay, it's a bit difficult one when compared to the previous problems. Okay, still we will see some more problems in future. Thank you.